Ever since we were born, our bodies have been fighting viruses. We're built to survive. We sometimes feel helpless when we do get sick, but let's take a look at what happens. All right, I'm going to use COVID-19. It's an antigen, which means foreign. It was a tough one too. Its first task is to make it through our first line of defense, our skin and linings. But waiting there are the cilia, these hair-like structures coated in mucus. We take a deep breath, and the cilia are going to trap most of the viruses that are trying to make their way in. Those viruses that survive can get hit by lysozymes, mucus and tears, powerful enzymes that destroy them. If we swallow the virus by accident, goblet cells producing also powerful mucus. And the skin itself has these sebaceous glands with a waxy oil called sebum that's going to trap the virus. And the epidermis itself is layer after layer of dead tissue. It's like a desert up there. Not much can survive. Waiting also are beneficial bacteria. They're going to outcompete the virus. But we know COVID was tough. Let's say COVID makes it through the first line. You might notice I put surface proteins on it. You see, all of the cells of our body have these surface protein markers. It helps us to know what self is. And it helps us to know when non-self enters our body. Because we don't want a bunch of organisms living in our body all the time. And so if they don't have a self marker like here, we kill them. I don't care if it's a splinter or a virus or bacteria, we kill them. We're good at that. We're very good at it. Okay, the second line. Let's say the virus got past our skin. These are what are called APCs, which means antigen presenting cell. I'll show you what I mean. COVID makes it in. Waiting for it is a big APC, such as macrophage. They have different shapes, but their job is the same. The macrophage is going to eat it, kill it. But what I think is cool is when it kills it, it's going to display the protein surface marker. See that? And you think, why would my own cell display the marker of an invader? What's the value there? Well, let's take a look. Because the second line has a backup. Usually the second line takes care of everything. Usually destroys the infection right here. But you get something tough like a COVID, we need to get the third line involved. These are the T cells, the helper T cells. So that APC is going to wander through the tissues and the fluids, and it's going to bump into a helper T cell. Here it is. And it's carrying that marker because it's like a flag. It's saying, hey guys, we are under attack. And the sucker is wearing this on the surface. It's like, you guys got to get bonded to this and help us out, man. We're getting swamped. The virus is coming in fast. The helper T is going to bond, and it's going to stimulate the production of cytotoxic T cells. The cytotoxic T cells are going to get busy. They're going to attach to the virus, and they release this toxin called perforin. Basically, they poke holes in the virus and kill it. The helper T is also releasing cytokines and histamines. You notice when you get sick, you get a fever, and you get lots of mucus, right? That's the action of the cytokines and histamines. They're going to make the blood vessels leaky. They're going to produce lots of fluid, and you're going to get a fever. Because when you get a fever, that gets all these cells really busy, and they're dividing fast, and they're furious and attacking. So you want a fever. All right? I mean, 102, I know it's uncomfortable, 101, but that means your defense systems is really cooking on high gear. Now we have these memory cells because we want to be ready if we get attacked again. And that's the whole idea behind vaccines. Okay, we don't inject like the virus. We get a yeast cell, we take a little bit of DNA out of the real virus, and we put it in something harmless like a yeast. We trick that yeast into displaying the surface marker of the virus. That's what we inject. It's safe. people still think like vaccines are like 50 years ago when we did just maybe inject the surface marker and maybe we sometimes got people sick. But nowadays, the recombinant DNA vaccines are amazing. I always get in line for those. All right, so we're destroying the virus all over the place, but let's say we're still losing. This is a tough one, this COVID. So now we call in the mighty B cells. They're in the backfield too. And look at these spiky heads. Those are antibodies. So the B cell is going to attach to COVID and it's going to start releasing all these antibodies. And these are drifting in our bloodstream. That's why we can know if a person has COVID just by finding these anti-COVID antibodies in their bloodstream. Okay, and what they do, let's get down to what they do. New COVIDs are coming in. Okay, this is a big infection. And so our body is attaching these antibodies directly to the surface of the COVID. And what that does is, well, let's look at regular. Okay, COVID that's unmarked, it might make it past the APCs and go deep into the lungs. But once they're marked with antibodies, it's like they are marked for destruction. And these APCs are just going to go straight and destroy these guys. It's like a beacon, a light shining on them, and they can't escape. So we rarely get sick, thank goodness, for our immune system.